Okay, so today we're going to be talking more about marginal choices, which we already sort of started talking about. Right? We talked about the golden rule, which was that marginal benefit equals marginal cost. Right? We want to set, or people are going to make decisions such that we're going to try to make that true. Right? And we're always going to keep that in the back of our minds. The golden rule. And it's wonderful. All right, so we've got our very simple rule, but as many simple things do, it sort of hides a lot of complexity in it. So we're going to be spending a little more time talking about what these sort of marginal choices really are and how they work, and getting a little bit more, at least intuition, as to how we can think about these sorts of marginal choices. So a little bit of a recap, a little bit of a restatement. So when economists say marginal, you can sort of read it as saying one more. The marginal benefit is the benefit that you get from one more unit. It's not how much benefit you get from having all of the units overall. It is how much benefit you get from one more unit. So the marginal cost is the cost of producing one more unit. Similarly, it's not the cost of producing all of them together. It is the cost of producing just one more, given that you've already made all the ones up to that. There are lots of other different kinds of marginal things that you can have. You can have marginal pretty much anything, things that we've not covered yet. Some of them we'll get to, some of them we won't. And again, if you're a math person, you can just think of sort of the derivative here. Right? This is what we're taking as the derivative. We're calling it marginal. So why are we focusing so much on this idea of marginal stuff, right? Well, one reason is that it really helps us think about how these optimal choices are made. A lot of choices are in the format of how much of something are you going to do? And we've emphasized really strongly this idea of opportunity costs and indirect costs and benefits, right? That in order to know how valuable something is, how good of an idea something is, we have to know what we're comparing it to, right? And in the context of how much of something am I going to do, you have, well, what are you comparing it to? Well, if you're going to do a certain amount of it, you're comparing it to doing a little bit more or a little bit less, right? Those are usually really the comparisons that you're making. So if we think that people are following incentives, then we're going to be able to predict their behavior by thinking about those marginal choices, right? By making those tiny little comparisons of just one more versus one less. And it's going to help us figure out, A, what they're going to do, and B, as the incentives change for individual stuff, what's going to change about their behavior, and which kinds of incentives are really going to matter, right? One of the interesting things that you tend to find once you start looking at marginal choices is that certain kinds of incentives don't really change behavior that much, right? If you have an incentive that really changes the total benefit of something, and it doesn't change the marginal benefit, then you might not expect it to actually change much about how much of something people do, right? Let's take a very basic example, right? So imaginary example. Let's imagine that we want to get people to stop smoking, all right? So we pass a new tax benefit that if you are not a smoker, if you smoke 0 cigarettes all year, then you get $1,000 back on your taxes. Okay. So let's think about what kinds of incentives this does or does not change. Right? So obviously it changes the incentives when you're comparing 0 cigarettes to 1 cigarette. Right? If you think about how many cigarettes am I going to smoke in a given day, right? It definitely changes the incentive between 0 and 1. Right? Because if you go from 1 to 0, you get $1,000 a year. Or if you go from 5 to 0, if you go from 10 to 0, whatever it is. It does not change the incentives comparing the different numbers of cigarettes you might smoke today, right? You smoke 10 cigarettes a day, you get no tax benefit. You smoke 11 cigarettes a day, still no tax benefit. The marginal benefit of going from 11 cigarettes to 10 is 0. There's no additional benefit of that, right? So we would expect that this tax incentive might get some people to quit smoking, but it should not get anybody to smoke less, right? Unless they're going to quit. So based on this, right, this is a policy that really only affects one sort of margin, and we wouldn't expect it to affect any of the other margins, right? And so we can anticipate how this might relate to the kinds of behavior that you see. So this is exactly what we're doing with supply and demand, right? We're predicting your buying behavior on the basis of the marginal benefit, not the total benefit, or ultimately backing out the marginal benefit from your buying behavior. We observe that you bought a certain thing at a certain price. We can sort of figure out a little bit what your marginal, what sort of benefit you derived from that good, or at least what you thought you were going to get. Same thing with supply, right? Like when we did a survey, right? Then how many sections of the survey you're willing to do. That was us figuring out your marginal costs. And this is going to help us explain a bunch of stuff, right? Why do demand curves slope down, right? Wouldn't you would expect that, if we're talking about a demand curve, if I say, okay, here's the quantity, let's say this is 10, 8, if I go to 11, maybe that'll be 7. This is saying the 11th unit is worth less than the 7th, than the 10th unit, right? It's kind of weird because you think that, okay, having 11 of something should be worth more than having 10 of something, right? Which is not inconsistent with this, right? This is not saying that having 11 is not as good as having 10. This is saying the 11th unit is not as good as having the 10th unit, right? Each additional one gives you just a little bit more, less than the one before. So even though having 11 total units would be better than having 10, then the 11th unit does not add as much for you. So in marginal benefit, each additional unit is worth less and less. If you're deciding how much of something to buy, the really relevant question is not how much value do you get from the whole bundle, it's how much do you get from a certain number relative to a certain difference. This is where this sort of downward sloping demand curve comes from. And also why we want to focus on that, because we're interested in what's going to really drive these choices, right? We want to make sure that the comparison is actually good, because that's the decision, that's the comparison that we're expecting that you're going to make. So let me give an example where this really sort of comes to the forefront. Let's talk about diamonds and water, right? There's actually an interesting result that we can get from this that's not entirely obvious. So some things we can know, some facts that we know. Water is essential to life. If we did not have it, we would die, and very quickly, right? Diamonds, however, are largely useless to most people. Most people have very little use for a diamond. At least in the sense of like, you're not going to die if you don't have it, right? They got uses, right? They're used in manufacturing and stuff. They look nice and pretty, and that is a real benefit. But they do not provide nearly as much benefit as water. And yet, diamonds are much more expensive than water, right? Why is that? I mean, if you think about anybody who has bought a diamond, probably is spending more on that diamond than they spent on water in like the past 10 years, right? The price difference is pretty stark. So why is that? Well, because the value that we place on things, the amount that you're willing to pay for stuff is not based on the total benefit, it's based on the marginal benefit. So while it is true that water is in absolute terms much more valuable to us than diamonds, we're not paying, or we're not determining our willingness to pay based on how much value it brings us overall. It's how much value the next unit brings us, because that's the unit we're considering buying. So we don't have a lot of diamonds, so the marginal diamond might be quite valuable to us, right? Going from 0 diamonds to 1 diamond or 1 diamond to 2 diamonds could bring you a lot of additional value. But for most of us in most parts of the world, we have access to all the water that we want. And so when we're thinking about how much we're willing to pay for more water, it's not about how much value does water bring to our lives as a whole, it's how much value do we place on having a little more water. And if you've already got enough water, a little more water is not that valuable to you, right? If you were in the middle of the desert and you were dying of thirst and someone said, hey, I got a gallon of water for you, give me your house, you'd say yes, right? But you're not in the middle of the desert dying of thirst, right? You're probably in your house and the tap is working fine. And someone says, hey, I brought a gallon of water to your house. Will you give me a quarter for it? You'd probably say, no, why would I do that, right? I don't need that. So, so the amount that you're willing to pay is based on how much something you already have, which can explain this distinction. So even if water is much more valuable overall, we still might not be willing to pay as much for it as we pay for something that we have less of to start, but are thinking about those first marginal units, right? So your first gallon of water is something that you pay anything for, right? If you had 0 water and somebody offered you a little, you'd pay a lot for it, otherwise you'd die. But by the time you get to your 1,000th gallon of water, the additional value, the marginal benefit that it brings you is pretty low. And that's where a lot of us are. So here's an example. Here's how we can draw that in terms of the demand curve, right? Remember, the demand curve encodes the marginal benefit for us. So what am I representing here? Well, I got 2 different graphs. This one's diamonds, the demand for diamonds, or the marginal benefit from diamonds. The same thing as drawing out the demand for diamonds. And over here is water. Okay. So I've drawn them in 2 different ways, right? Water is sort of up and a little bit higher, and it's also a little bit steeper than the diamond. So what am I saying here? So one, notice at low quantities, the value of water is much higher, right? This is the, thirsty in the desert scenario where you have no diamonds, but also no water. You pay a lot more for water than when you have no water than you pay for a diamond when you have no diamonds, right? So at the first couple of units, water is super valuable, way more valuable than a diamond. But they both decline, right? They both slope down. And as you move to the right for both of them, the marginal value of what you're willing to pay for another unit drops. And then we have to ask ourselves, okay, well, then which point on these curves are we at right now? For the diamonds, we probably do not have a lot of diamonds. Most of us do not own many diamonds. I don't own any diamonds, right? And so we're down here at the part where, even though it started lower, we're still at this highest part of the diamond curve, right? So we can put, for a given quantity that we have, here's the marginal benefit that we place on diamonds. Over here for water, we have a lot of units already. So even though it started higher, we're out here way on the right after a big decline. And so the value that we are placing on that additional water is lower than the value that we place on the diamonds, right? And so if you think, okay, well, and where's that part about diamond or about water being super valuable to life? Well, the total benefit that we get from water, right, which is of course much higher than the total benefit we get from diamonds, is this whole area, right? Everything underneath that triangle, which is much bigger than this triangle, right? So we are getting overall much more value from water, but the amount that we're willing to pay for the next unit is much lower.